Hi everyone, welcome to Textpert Solutions. Today in this video we are going to learn to see what is Laplace transform. Introduction to Laplace transform. So Laplace transform is a method used to solve the differential equations with initial and boundary conditions. In general, the differential equations can be solved by first finding the general solution, then evaluating that general equation using the arbitrary constant with initial condition. So generally the differential equations can be solved using these two steps. So Laplace transform eliminates these two steps. By using Laplace transform, we generally solve with in the initial conditions directly. If we use the Laplace transformation method to solve the differential equations, the step is very simple. We directly solve with the initial conditions. But if you are not using the technique of Laplace transform, then you need to find the general solution first, then evaluating with the arbitrary constant. So with the use of Laplace transform, we eliminate these two steps and we directly solve by using the initial conditions. So now let's see what is the definition of Laplace transform. So Laplace transform, so first let us consider f of t is a real valued function. Real valued function at a time t is greater than or equal to 0. So the Laplace transform of the function f of t can be written as integration from 0 to infinity e to the power of minus st into f of t dt, where s is a real or a complex number. In general, we can write it as capital F of s is equal to Laplace transformation of f of t is equal to integration from 0 to infinity e to the power of minus st into f of t dt. Now let's see the properties of Laplace transform. There are two properties of Laplace transform. There are two basic properties of Laplace transform. That is, first, if f of t and g of t are two functions of t and k is a constant, then the first property is Laplace transform of constant into function is always equal to k into Laplace transform of f of t. And the second one is Laplace transform of f of t plus g of t is equal to Laplace transform of f of t plus Laplace transform of g of t. Now let's solve the first one. We have Laplace transformation of f of t. According to the definition, the transformation of f of t, Laplace transformation of f of t can be written as integration from 0 to infinity e to the power of minus st into f of t into dt. This is the definition of Laplace transform, we already know. So what will be the Laplace transformation of a constant into a function? That will be equal to integration from 0 to infinity. Now consider the term this k into f of t as f of t. Then it will be equal to e to the power of minus st into f of t dt. Now replacing f of t with the original value e to the power of st, here f of t we have taken k into f of t. Now replace f of t with k into f of t dt. Now since it is a constant, it will be k, it will come outside, so k into integration from 0 to infinity e to the power of minus st f of t dt. So this is the Laplace transformation of f of t. So this can be replaced with L of f of t, and the k will always come here. So LHS is equal to RHS, Laplace transform of k into f of t is equal to k into f. This is the first property of Laplace we have seen. Now the second property is Laplace transform of f of t plus g of t is equal to Laplace transformation of f of t plus Laplace transformation of g of t. Now just take the whole term as one function just for consideration. So according to the definition of Laplace, so Laplace transformation of f of t is equal to integration from 0 to infinity e to the power of minus st into f of t dt. 0 to infinity e to the power of minus st. Now replace f of t with these two terms, so it will become f of t in plus g of t 0 to infinity. Now just multiply with e to the power of minus st f of t plus e to the power of minus st g of t into dt. Now we can split it 0 to infinity e to the power of minus st f of t dt plus integration from 0 to infinity e to the power of minus st g of t into dt, since here it is plus 2. Now so this will become Laplace transformation of f of t. So this is here the term e to the power of minus st f of t. This is the form of Laplace transformation of f t definition. Now this will become the Laplace transformation of function g of t, because it is of the form integration from 0 to infinity e to the power of minus st f of t dt. Here in place of f of t it is g of t. So this is Laplace transformation of g of t. So LHS is equal to RHS. If you have any doubts with this, you can you can ask your doubts in the comment box. Thanks for watching.